Hello students, so welcome back to the revision session again. So in the last revision session we have completed central tendency and dispersion, right? So in this revision session let us take up the next topic and next important topic, correlation and regression. Now let us try to understand this concept of correlation and regression. If you see, this correlation and regression is of weightage of around 4 to 5 marks, right? Now, let us try to analyze this chapter. Now, first, let us try to understand regarding correlation. Then we will have a insight regarding regression. And then at last, we will try to understand regarding univariate data and bivariate data. Now, my dear friends, first let us understand what is correlation. Correlation is nothing but it's the mathematical relation between two variables. If you are trying to calculate the relation in terms of max in two variables, we call it as correlation. Now, try to see these three examples. In the first example, if you see, we have variable x and we have variable y. If you see, in the first case, we have variable x and we have variable y. If you see, variable x is increasing and variable y is also increasing, right? You see here, variable x is increasing and variable y is also increasing. Both x and y are increasing. Now, when both x and y are increasing, can I say both x and y are having direct relation, right? Or can I say they are having positive relation? Now, in physics, you might say that they are directly related, but in statistics, you cannot say that they are directly related. Here, the relation between x and y is somewhat like this. Both are increasing. So, instead of saying they are directly related, I will say that they are positively related. R is equal to +1. Now, what is this R? R is nothing but correlation. We express correlation in terms of letter R. Now, if you see in the next case, the variable x is increasing, variable y is decreasing. In terms of mathematics or in terms of physics, you say that they are inversely related. But in statistics, you cannot say that they are inversely related. Here, x is increasing, y is decreasing. We term R is equal to -1. That is a negative correlation. If both are moving in the same direction, positive correlation. If they are both are moving in a different direction, it is negative correlation. Now, if you see in the third case, x is decreasing, reaching 0, and again it is increasing. But why it is going on increasing? Means there is no relation between x and y. I can term correlation is equal to 0. Now, in these cases, there are perfect relation between x and y. So, you said that r is equal to +1, r is equal to -1, and r is equal to 0. But this is not the instance, my dear friends, in each and every case. In each and every case, we are supposed to calculate the correlation. How we are supposed to compute the correlation? That is what we are supposed to study in this chapter. Now, I am saying r, right? This r lies from -1 to +1, both inclusive. What do you mean by both inclusive? Both inclusive means we are supposed to consider -1 as well as +1. Now, what do you mean by r being -1? R being -1, we call it as perfect negative correlation. Now, what is perfect and negative correlation? Perfect negative correlation means x and y move in a different direction. Now, what is this x and y moving in a different direction? If x increases, y decreases, or if x decreases, y increases, then in such circumstances, we call it as a negative correlation. Okay. Now, what is +1? +1 is nothing but perfect positive correlation. Perfect positive correlation. Now, what is this perfect positive correlation? Perfect positive correlation means here x is increasing means y is also increasing, or x is decreasing means y is also decreasing. We call it as perfect positive correlation. Means what's happening here, my dear friends? In earlier case, x and y are moving in opposite directions. But in this case, x and y are moving in same directions. I hope the point is clear. Now if it is 0, 0, what is this 0, man? There is no correlation at all, or there is a spurious correlation, or there is a nonsense correlation. No correlation, or we call it a spurious correlation, or you call it as nonsense correlation. Now I am writing R is equal to -1 to +1. Can I say they are numbers? Yes. So correlation is nothing but they are expressed in terms of pure numbers. And my dear friends, do remember correlation is a unit free measure. What measure? Unit free measure. What measure? Unit free measure. Now tell me, it's a unit free measure, right? Is it a relative measure or absolute measure, my dear friends? It's a relative measure. Why it's a relative measure? Because it's a unit free measure. So I hope the basic point is clear. So correlation is a pure numbers, they are unit free measures, and they are also called as relative measures. So what we are trying to develop here? We are trying to develop a mathematical relation. What relation? Come on, mathematical relation between two or more variables. We call it as correlation. Now we have total 6 types of correlations, my dear friends. First type is positive correlation, second one is negative correlation. We have already discussed what is this positive and negative correlation. Third one is simple correlation. Simple correlation means if you are calculating the correlation only for two variables, it is simple correlation. Multiple correlation. Multiple correlation means if the correlation is calculated for more than two variables, like 3, 4, 5, 6, so on, it is called as multiple correlation. Next, we don't have multiple correlation in our syllabus, we have only simple correlation in our syllabus. In the next instance, if you see, we have curvy linear correlation and curvy linear correlation. Linear correlation means if x and y are moving in a same ratio, we call it as linear correlation. If x and y are moving in a different ratio, we call it as curvilinear correlation. So I hope the basic point is clear, my dear friends. Now, so we have some examples here. We are supposed to decide what is the correlation here, whether correlation is positive or whether correlation is negative. If you see, he is saying rainfall and yield of a crop. Can I say somewhat like this? As the rainfall increases to some extent, yield of a crop also increases, because if it extends, if it goes beyond that, it will be a floods, right? So only to some particular extent, if rainfall increases, can I say yield also increases? So +1, both are moving in same direction. Next, age of husband and age of wife. Of course, if husband age increases, wife age increases over a period of time. So +1. Day temperature and sale of cool drinks. As the day temperature increases, people tend to consume more cool drinks, right? So it means, can I say, as day temperature increases, sale of cool drinks also increases. Positive correlation. Next, sale of day temperature and sale of woolen garments. Day temperature and sale of woolen garments means when the day temperature is increasing, will you tend to wear woolen garments? No, right? I hope you don't show any interest in wearing woolen garments when the day temperature is increasing, right? In that case, when you are not showing interest to wear, why the hell are you supposed to buy those garments, right? So as the day temperature increases, sale of woolen garments reduces. So correlation is -1. Now acceleration and speed. The more you accelerate, the more speed your vehicle goes. The less you accelerate, the less speed your vehicle goes. +1. Demand and price with respect to demand. As the demand increases, price increases. As the demand decreases, price decreases. Be careful, my dear friend. He is saying with respect to demand. So it is supposed to be +1. Demand and price with respect to price. I guess here functions a variable called as law of demand. So as the demand with respect to price, as the price increases, people tend to consume less. So demand decreases. As the price decreases, people tend to consume more. Demand increases. So relation is -1. Cost per unit and production. What do you think for cost per unit and production? Can I say as the production increases, my cost per unit decreases? What? How? Say for example, I am taking a classroom on rent. I am taking a classroom on rent where the rent of classroom is 1 lakh rupees. And I am having 10 students in my classroom, then what will be the burden on one student? Can I say it will be somewhere around 10,000, right? Now say instead of 10 students, I am having 50 students. What will be burden on each student? Simple, my dear friends, it will be 2,000. No, they are 1 lakh students and 1 lakh is a rent. What will be burden on each person? 1 rupee. Means what's happening? As the students are increasing, the burden on students to bear the fixed cost is decreasing. So comes with the cost per unit and production. So relation is -1. Shoe size and intelligence. From where we got this shoe size and intelligence? How can one person calculate the relation between shoe size and intelligence, my dear friends? It's not possible, so it is 0. Okay. Next, methods to compute correlation. It's okay, now in these examples you said what is a correlation, right? But sometimes variables x will be given, variable y will be given in terms of numerical terms. In that cases, how we are supposed to compute the correlation? So believe me, my dear friends, there are total 4 methods in order to compute the correlation. Now what are those 4 methods? Those 4 methods are somewhat as follows. The first method what we have is called as scatter diagram method. The second method what we have is concurrent deviation method. Third method, what do you have? Third method, we call it as Spearman rank correlation coefficient. The fourth method what you have is Karl-Pearson correlation coefficient. These are the 4 different methods what we have under study. Now first, my dear friends, if you see in these 4 methods, what is the easiest method? The easiest method would be concurrent deviation method. What would be the best method? The best method would be Karl-Pearson correlation coefficient method. Which data is based on qualitative data? Which method is based on qualitative data? Spearman rank correlation is based on qualitative data. What is the first method? Scatter diagram is the first method. So I hope the basic point is clear, my dear friends. So among all these 4, concurrent deviation method is a easy method. Karl-Pearson correlation coefficient is the best method. Spearman rank correlation coefficient is based on qualitative data. Next, scatter diagram is the first method. Okay. So I hope the basic point is clear, my dear friends. Now let us see scatter diagram method. In scatter diagram method, we have a very big disadvantage. What is that disadvantage what we have in scatter diagram method? Because of which several other methods were developed. Now if you see what disadvantage we have in scatter diagram method, it is somewhat like this. Scatter diagram method, it is used to compute only and only the nature of correlation. What my dear friends? Nature and correlation, but we are unable to calculate degree of correlation here. Means what we are supposed to do in this method, we will take variables x and variable y and we'll plot it in a graph. When we have plotted them in the graph, we can just say either they are positively related or negatively related, that's it. We cannot measure to what extent they are positively related or to what extent they are negatively related. Okay. So basically only nature can be calculated, my dear friends, but degree of correlation cannot be calculated. Okay. So I hope the basic point is clear, right? Shall we proceed further? Yes. Now look here, my dear friends, in the first 2 cases, that is in the first 2 graphs, what's happening in the first 2 graphs? In the first 2 graphs, the points are moving either towards upward or either towards downward in a straight line. Remember one thing, my dear friends, if it is moving upwards, it will be a positive correlation. If it is moving towards downwards, always and always and always, the slope will be negative, so negative correlation. Now, if they are moving in upwards and they are moving in exact straight line, in what line? They are moving in a straight line. In that case, we have perfect positive correlation. They are moving downwards and again they are moving in a straight line. We have perfect negative correlation. They are moving upwards from left to right in a packed way. Then we have high degree of positive correlation. Next, when we are moving in the third graph from left to right downwards, we do have here negative correlation. Now, in the next two cases, if you see, the points are moving not in a packed way, but they are moving in a scattered way. Okay, here high degree of negative correlation. So in the next two cases, if you see, the points are moving from left to right downwards and right to left to right downwards and left to right upwards, not in a packed way, but in a scattered way, my dear friends. So in this case, we have low degree of negative correlation, low degree of positive correlation. So in either of the cases we have low degree, but if they are moving upwards positive, they are moving downwards negative. In these two cases, my dear friends, we cannot say whether the points are moving from left to right or right to left. So in these two cases, there would be no correlation. Okay, so I hope the basic point is clear, my dear friends. Now let us go for the next method, that is concurrent deviation method. So students, we have done with scatter diagram. So if you see, scatter diagram was a graphical method, but there we were calculating only the degree of correlation, sorry, only the nature of correlation, nowhere we were calculating the degree of correlation. Now concurrent deviation method. In concurrent deviation method, we are supposed to calculate the correlation using a concept called as concurrence. Now what is this concurrent? Concurrent, it is nothing but a plus symbol. A plus symbol is basically called as concurrent. So in concurrent deviation, how will you calculate the correlation? The value of R is supposed to be plus or minus root of 2c minus m whole divided by m. Now C is nothing but number of concurrence, that is number of plus symbols, and m is supposed to be n minus 1 observations. Now if 2c minus m is greater than 0, outside symbol would be positive. If 2c minus m is less than 0, outside the symbol would be negative. Now how we are supposed to calculate correlation and the concurrent deviation method? Let us try to understand with one basic example. Now if you see, for 35, is there any number before 35 for comparison? Yes, I guess there is no number before that for comparison, so let me take it as 0, because there is no number for comparison. Now see, from 35 to 38, what's happening? Is it increasing or is it decreasing, my dear friends? I hope it is increasing, right? So symbol would be plus. 38 to 40, increasing. 40 to 33, decreasing. 33 to 45, increasing. 45 to 48, increasing. 48 to 49, increasing. 49 to 52, increasing. Now let us see for y. There is no number for comparison. 36 to 35, decreasing. 35 to 31, decreasing. 31 to 36, increasing. Decreasing, 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 decreasing. Now let us multiply c of x into c of y, plus into minus, 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 minus. So can I say there is no plus symbol, so C is supposed to be 0. Now applying in our formula, R is equal to root of 2C minus M divided by M. Now total how many observations are there, my dear friends? 1, 2, 3, 4, 5, 6, 7, 8. So what is supposed to be N? Sorry, M. N is supposed to be 8. So M is supposed to be 8 minus 1, 7. So root of 2C, that is 2 into 0, 0, minus 7 by 7. Since inside 2C minus M is minus 7, which is less than 0, outside symbol should be minus, and coefficient of correlation is supposed to be minus 1. Okay, that is perfect negative correlation. I hope the point is clear, my dear friends, how we are supposed to compute the correlation under concurrent deviation method. Now let us try to apply this method in one more example. Is there any number for comparison? No. 9 to 5, what's happening for my dear friends? 9 to 5, what's happening? It's decreasing. 5 to 11, increasing. 11 to 16, increasing. 16 to 35, increasing. Now let us see for y. There is no number for comparison. 7 to 3, decreasing. 3 to 11, increasing. 11 to 9, decreasing. 9 to 12, increasing. Now let us multiply 0, plus symbol, minus symbol, plus symbol. So number of concurrents are supposed to be 3. Now applying in the formula, R is equal to plus or minus root of 2C minus M divided by M. That is root of 2 into 3 is 6 minus M. M is nothing but n minus 1, right? If you see what is the n, my dear friends, 1, 2, 3, 4, 5. What is 5 minus 1? 4 whole divided by 3. Sorry, whole divided by 6. That is nothing but, my dear friends, root of 2 divided by 6. That is nothing but 1 divided by root 3 is supposed to be my answer. So small correction, my dear friends, this is not so 6 minus 4 divided by 4, so 2 divided by 4, that is 1 by root 2 is supposed to be my answer. Is that clear, my dear friends? So basically what we are supposed to do here, we are supposed to calculate number of concurrents. After computing number of concurrents, just you are supposed to substitute in the formula under root 2C minus M divided by M. If 2C minus M is greater than 0, outside symbol would be positive. If 2C minus M is less than 0, outside symbol would be negative. Now, Spearman rank correlation coefficient. My dear friends, this method is used in terms of qualitative data. Believe me, my dear friends, this person has made this method when he was attending a fashion show. I don't know what interest this person found when attending a fashion show. He has developed such type of methods. Okay. Now, Spearman rank correlation coefficient. What are supposed to be the formulas? When ranks are not repeated, in that case, the formula will be 1 minus 6 into summation of d square divided by n into n square minus 1. When ranks are repeated, the formula is supposed to be 1 minus 6 into summation of d square plus 1 by 12 into m1 cube minus m1 plus 1 by 12 into m2 cube minus m2 so on whole divided by n into n square minus 1. So these are supposed to be the formulas. Now always remember, my dear friends, at any cost the summation of d must be equal to 0. If it is not equal to 0, there is some problem with your computation, and summation of d must compulsory be equal to 0. Be careful, summation of d must be equal to 0. Now here it would be better if you remember these values, my dear friends. If m1 is equal to 2, then 1 by 12 into m1 cube minus m1 is supposed to be 0.5. If m1 is equal to 3, then it is supposed to be 2. Okay, enough. 2 and 3 more than enough. Now let us see a concept when ranks are not repeated. Now, if you see, first see variables x, my dear friends. What is the highest number here? Can I say highest number is supposed to be 77? So let us give first rank to 77. What is the next highest number? You are right, my dear friends, 75. Next highest number, can I say it is supposed to be 58? Yes. Next highest number, can I say it is supposed to be 50? Yes. Next highest number, can I say it is supposed to be 43? Next highest number, my dear friends, can I say it is supposed to be 34? Next highest number, we are supposed to have 29. Next highest number 28. Next highest number 24. Next highest number 19. So if you see, total 10 observations, 10 ranks have been given. Now let us give ranks for y. What is the highest observation, my dear friends? Can I say 79 is the highest observation? Next, after 79, what is the next highest observation? Can I say 70 is the next highest observation? 69 is the third highest observation. Next, I guess 65 is supposed to be the fourth highest observation. 63 fifth highest. 62 sixth highest. Next, if you see, 59 is supposed to be seventh highest. 56 is supposed to be eighth highest. 55 ninth highest. 54 10th highest. Okay. So my dear friends, we have given ranks for x, we have given ranks for y. Now let us compute d. D is nothing but difference in ranks. 3 minus 6 minus 3, 0, positive 3, 2, 8 minus 4, 4, 9 minus 10, minus 1, minus 1, minus 1, minus 2, minus 1. So, mine 3, 4, 7, 8, 9, 3, 4, 5, 6, 7, 8, 9. Yes, my dear friends. So, value of D is at any cost supposed to be equal to 0. So, all our ranks, every computation is correct. Now, let us verify D square. What is minus 3 square? 9, 0, 9, 4, 16, 1, 1, 1, 4, 1. So if you calculate the total, my dear friends, 9 plus 9 plus 4 plus 16 plus 1 plus 1 plus 1 plus 4 plus 1, the value is supposed to be 46. Okay. Now let me apply in the formula. 1 minus 6 into summation of d square divided by n into n square minus 1. That is 1 minus 6 into 46 whole divided by 10 observations are there, right? So 10 into 100 minus 1. So 6 into 46 divided by 99 divided by 10 minus 1. So it is supposed to be 0.7212. Okay. Is it clear, my dear friends? So how we are supposed to compute here? So what is the formula? What is the value of correlation here? 0.7212. So this is how you are supposed to do when the ranks are not repeated. Now let us take an example and solve it and see what the situation would be when the ranks are repeated. Now first let me give ranks for x. What is the highest observation? 15. Now second and third rank is repeated. When the ranks are repeated, you are supposed to take the arithmetic mean of those ranks. So 2 plus 3 whole divided by 2, which is supposed to be 2.5. So for 9 it is 2.5. For 9 it is 2.5. Don't keep 3. Rank is supposed to be 4, my dear friends. Be careful. Now let us give ranks for y. First rank is for 11. Second rank, third rank, fourth rank is repeated, which is equal to 2 plus 3 plus 4 divided by 3, which is 3. 3, 3 and 3. Now let us compute difference. 4 minus 3, 1. 2.5 minus 3, minus 0.5, minus 0.5 and 0. Summation of d square 1, 0.25, 0.25, 0, and 1.5. Now let us apply in our formula, my dear friends. 1 minus 6 into summation of d square plus 1 by 12 into m1 cube minus m1 plus 1 by 12 into m2 cube minus m2 whole divided by n into n square minus 1. That is nothing but 1 minus 6 into summation of d square is 1.5. m1 is nothing but these things. m1 is 2 and m1 is 3. If m1 is 2, what is the value, my dear friends? I said you if m1 is 2, value is 0.5 and 2. So let me take the same thing, 0.5 plus 2 whole divided by n into n square minus 1. n is 4, 4 square 16 minus 1. So 1 minus 6 into 4 whole divided by 4 into 15. That is nothing but 6 into 4 divided by 4 divided by 15 minus 1. So correlation is supposed to be positive 0.6. So I hope the basic point is clear, my dear friends, how we are supposed to compute the correlation. So till now we have seen total 3 different methods. First method what we have seen is Spearman rank correlation. First method what we have seen is scatter diagram method. Next method what we have seen is concurrent deviation method. Third method what we have seen is rank correlation coefficient method. Fourth method, most important method, Karl Pearson correlation coefficient method. Kala admi. Karl Pearson correlation coefficient method or product movement correlation coefficient method. My dear friends, this is one of the best method. Why you call it one of the best method? Leave the scatter diagram aside because there is nothing in that. If you see concurrent deviation method, it is based only on plus and minus symbols, right? Next, one more thing, if you see Spearman rank correlation coefficient, it is based only on ranks, right? It's what's happening, my dear friends, in these two things what we have taken, we haven't taken original observations, we have taken some conclusion from the original observations. That's the reason these two are not the best methods. But in this case what we are supposed to do, we are supposed to take the original methods, that is we are supposed to take original values in Karl Pearson correlation coefficient. That's the reason we are supposed to call it as best method. Now my dear friends, what is supposed to be the formula here? Here formula is supposed to be R is equals to ratio of covariance and standard deviations. Ratio of covariance and standard deviations, which is supposed to be covariance of xy divided by standard deviation of x into standard deviation of y. Okay. Now what is covariance, my dear friends? Covariance is nothing but it's a joint variance. What variance? Joint variance of two variables x and y. If you compute the joint variance of two variables x and y, we call it as covariance. What are the limits for correlation, my dear friends? Minus 1 to plus 1, right? But limits of covariance are minus infinity to plus infinity. It can assume any value from minus infinity to plus infinity. There is a condition for covariance. The covariance is always supposed to be less than or equal to standard deviation of x into standard deviation of y. Now why like this, my dear friends? R is always supposed to be less than or equal to 1, right? We know R is always supposed to be less than or equal to 1, right? R is always supposed to be less than or equal to 1. Now what is the formula for R here? Covariance of xy divided by standard deviation of x into standard deviation of y less than or equal to 1. We are supposed to do cross multiplication. I am going to get the same resultant. Okay. So this is an important condition. Two sums in your ICA material and set B are based on this condition itself. So what is the formula for R, my dear friends? Covariance of xy divided by standard deviation of x into standard deviation of y. Sir, what is supposed to be the formula for covariance? Covariance formula will be summation of x minus x bar into y minus y bar whole divided by n. We already know standard deviation formulas, root of summation of x square by n minus mean square, or root of x minus x bar whole square divided by n, right? Now if you apply all the formulas, the formula is going to become n into summation of xy minus summation of x into summation of y whole divided by root of n into summation of x square minus summation of x whole square into root of n into summation of y square minus summation of y whole square. These are supposed to be the formulas for Karl-Pearson correlation coefficient. Now my dear friends, let us do one small thing. For the given example what we have here, let us compute Karl-Pearson correlation coefficient using this formula. Now taking this example, my dear friends, x and y variables. Now what is supposed to be total of x? 1 plus 2 plus 3 plus 4 plus 5, that is nothing but 15. What is supposed to be total of y? 8 plus 6 plus 7 plus 5 plus 5, which is supposed to be 31. Now what we are supposed to take here, my dear friends, we have summation of x, we have summation of y. Now let us take xy. 8 into 1 8, 6 into 2 12, 7 into 3 21, 5 into 4 20, 5 into 5 5 into 4 20, sir. 5 into 4 20, 5 into 5 25. Now let us add all this, my dear friends. 8 plus 12 plus 21 plus 20 plus 25, which is supposed to be 86. Now let us calculate x square. 1 square, 1, 2 square, 4, 3 square, 9, 4 square, 16, 5 square, 25. Now let us calculate the sum of all this. 1 plus 4 plus 9 plus 16 plus 25, which is supposed to be 55. Now y square. 8 square 64, 6 square 36, 7 square 49, 5 square 25, and again 5 square is supposed to be 25. Now let us add all these things, my dear friends. 64 plus 36 plus 49 plus 25 plus 25, which is supposed to be 199. Now my dear friends, let us substitute all these values in our formula and let us get the answer. So n is 5. Summation of xy 86. Summation of x into summation of y 15 into 31 whole divided by root of n is 5. Summation of x square is 55 minus summation of x whole square 15 whole square into root of n into 5 into summation of y square 199 minus summation of y whole square 31 whole square. Now 5 into, what is the numerator, my dear friends? 5 into 86, 15 into 31, which is supposed to be minus 35. Okay. Now let us compute the denominator value, my dear friends. 5 into root 50 into 34. Now let me apply this formula, my dear friends. Sorry for that. not 35 my dear friends, rather it is 34. Now, so what is supposed to be the value? 35 divided by 50 under root equal to divided by 34 under root equal to, so it is supposed to be minus 0.84. So what is the value my dear friends? Minus 0.848, which is approximately equal to minus 0.85. So I hope my dear friends all these basic points regarding all the four formulas are clear, right? Now there are few properties what I want to discuss with you regarding this correlation my dear friends. Now, so what are those properties? Among all these properties of correlation, first property what I am discussing with you is one of the most important property. Very simple my dear friends. First property, correlation is not affected by change of scale and change of origin. Sir, what, are you crazy? Yes my dear friend, change of scale and change of origin. Now what I am saying, your correlation is not affected by change of scale and change of origin. What is the meaning of this my dear friends? Very simple. If all the observations are increased or decreased by constant, if all the observations are multiplied or divided by constant, correlation remains unaffected. Okay. Come on my dear friends, revise with me once again. Central tendency affected by both change of scale and origin. Dispersion affected only and only by scale, not by origin. But correlation is not at all affected by any of these, not affected by scale, not affected by origin. But my dear friends, it is affected by magnitude. But affected by magnitude. Sir, what is this but affected by magnitude? Simple my dear friends, let me discuss one small example related to this with you. 1 minute, give me 1 minute break. Let me find out that question. Now look my dear friends, say for example, it has been said that correlation of xy, Rxy is given as 0.8. We are supposed to compute RUV. Okay. Now, we are supposed to, he gave us 4 different equations. First equation is been given as 2u plus 3x plus 4 is equal to 0. One more equation is given as 4v plus 16y plus 11 is equal to 0. Okay. Now my dear friends, when equations are given like this, when Rxy is given and RUV is asked to compute. Now do one thing, what is given my dear friends? Xy is given, right? Now convert them into this format. Which format, sir? AU plus BX plus C is equal to 0. Next, DV EY plus F is equal to 0. Now since Rxy is given, you are supposed to compare the values of x and y. Okay. If x and y are having opposite symbols, the final answer is supposed to be minus. If x and y are having same symbols, the final answer is supposed to be plus. Okay. So I hope the basic point is clear my dear friends, but the value what I have given Rxy 0.8, that Rxy 0.8 is never going to change. It is going to remain the same. Okay. Now compare here my dear friends. If you look at the x and y, can I say we are not bothered regarding the values of x and y because it is not affected by scale and origin. We are bothered only and only regarding the symbols of them. Now x and y, what are the symbols? Both are having positive symbols. Both are having same symbols. Final answer is plus 0.8. Now instead like this my dear friends, it is given as, it is given somewhat like this, 2u
minus 3x plus 4 is equal to 0, 4v plus 16y plus 11 equal to 0. In this case, my dear friends, if you look at
X and Y symbols both are having opposite, right?
so final answer is supposed to be minus 0.8. Next, in the third instance, 2u minus 3x plus 4 equal to 0 and 4v minus 16y plus 11 equal to 0. In this case, can I say u and x and y both are having same symbols? Now, since they are having the same symbols, answer will be plus 0.8.
Now, my dear friends, sometimes Rxy will be given as minus 0.8. In that case, you apply the rule of opposite and same. Don't apply the rule of minus and plus. Okay, be careful. Not every time minus and plus. If plus is given, you will get minus and plus. If minus is given, you will get plus and minus. Be careful regarding what terms and terminology what you are taking here. So, first point, my dear friends, so correlation is not affected by change of scale and correlation is not affected by change of origin, but it is affected only and only by magnitude. How will you see whether it is affected by magnitude or not? If Rxy is given, convert them into our standard format and make sure you compare the X and Y symbols. Okay. So, I hope the basic point is clear, my dear friends. Sometimes AU, DV both will have different symbols. In that, make sure that they both have same symbols. Then only you can compare X and Y. If they are having different symbols, you cannot compare X and Y. They must have same symbols at any cost. Okay. I hope it is clear, my dear friends.
Now, next point, point number 2.
So, first point we have studied that correlation is not affected by change of scale, correlation is not affected by change of origin, it is affected only and only by magnitude.
Now, next point, my dear friends, coefficient of determination, most favorite bit of ICI. Coefficient of determination is supposed to be r square, or it is supposed to be explained variance divided by total variance. Now, what is supposed to be this coefficient of determination? Say for example, r is equal to 0.7. Then r square will be equal to 0.49 or 49 percentage.
Now, what does this 49 percentage indicate, my dear friends? It says that 49 percentage of the variables are dependent on each other. Means because of this 49 percentage of the variables, you got correlation as 0.7. Had 100% of the variables would have been dependent on each other, we would have got the correlation as +1 or -1. But here 100% are not dependent on each other, only and only 49% are dependent on each other. So, you got correlation as 0.7. Okay. So, what is the formula for coefficient of determination, my dear friends? R square.
Next, third point, coefficient of non-determination is supposed to be 1 minus r square, or unexplained variance divided by total variance. What is the formula, my dear friends? Unexplained variance divided by total variance. In this case, 1 minus 0.49, which is equal to 0.51 or 51 percentage.
Now, what does this 51 percentage indicates? 51 percentage indicates that 49 percentage of the variables are dependent on each other. 51 percentage of the variables are not at all dependent on each other. Since they are not dependent on each other, so R became 0.7. They couldn't achieve that 0.3 extra because of these 51 percentage of the variables. So, I hope it is clear, my dear friends.
Next, fourth one, coefficient of alienation. It is supposed to be root of 1 minus r square. Next, standard error. Standard error is supposed to be 1 minus r square divided by root n. Next, probable error, important concept. Probable error 0.675 into 1 minus r square divided by 0.675. 1 minute, my dear friends.
So it is supposed to be 0.675 into 1 minus r square divided by root n. Now what is the use of this probable error?
There are total two uses of this probable error, my dear friends. Sir, what are those two uses of probable error? First one is to compute the limits of population. First one is to compute the limits of population, where upper limit is supposed to be r plus probable error and lower limit is supposed to be r minus probable error. Next, we can even use it to compute the significancy of correlation. Now, if r is greater than or equal to 6 probable error, we can say it is really significant. If it is r is less than 6 probable error, we can say no, it is not at all significant, right? So, my dear friends, these are the 6 properties what I want you to know regarding this correlation part. Okay, so dear friends, here let us end the part of correlation. In the next part, I have graded around 20 to 25 best sums on correlation. We will be solving those sums in our next part. Along with that, we will have a revision on regression. We will have a revision lecture on regression, and we will be completing that regression as well. Okay, so I hope the basic point is clear, my dear friends, regarding this correlation. Make sure you download the next lecture. Make sure you download the document what I provide you in the description. And my dear friends, one small request, make sure that you like the video, share the video, subscribe to us, and make sure that you don't forget to hit the bell icon for the further notification, and make sure you share the video to your friends who are in need. Okay, because a friend in need is a friend indeed. Okay, chalo, let me take please.